Today we are talking about the fifth module of computer graphics and visualization regarding computer animation. The contents goes like this: raster method for computer animation, design of animation sequences, traditional animation techniques, general computer animation functions, and we will discuss some of the OpenGL animation procedures or functions. As we already know that animation is something fascinating to all of us since childhood, advertising animations often transitions one object shape into another. For example, transforming a can of motor oil into an automobile engine. We can also generate computer animations by varying camera parameters such as position, orientation, or focal length. And variations in lighting effects are other parameters and procedures associated with illumination and rendering, which can be used to produce computer animations, which we have already discussed in the previous topics. For constructing basic methods for motion sequences, we have two important methods or methodologies such as real-time animation and frame-by-frame animation. In real-time computer animation, each stage of the sequence is viewed as it is created. Thus, the animation must be generated at a rate that is compatible with the constraints of the refresh rate. Whereas in frame by frame, each frame of the motion is separated, generating and storing it. Later frames can be recorded on film or they can be displayed consequently on a video monitor in real-time playback mode. Let us now discuss raster methods for computer animation, where because the screen display is generated from successively modified pixel values in the refresh buffer, we can take advantage of some of the characteristics of the raster scan or raster screen refresh process to produce motion sequences quickly. For an example or for a complex scene, one frame of the animation could take most of the refresh cycle time to construct. In that case, objects generated first would be displayed for most of the frame refresh time, but objects generated towards the end of the refresh cycle would disappear almost as soon as they were displayed. Therefore, for very complex animations, the frame construction time could be greater than the time of refresh to the screen, which can lead to sometimes erratic motion and fractured frame displays. Moving on to double buffering, some graphic libraries that permits such as typically which have one function for activating the double buffering routines and other function for interchanging the roles of the two buffers, especially in the OpenGL programs we have seen swap buffers and all. So such functions will be provided so that we can refresh the buffers continuously. Before discussing more about the swapping of buffers, let us discuss one more topic called design of animation sequences, where a construction of an animation sequence can be a complicated task, particularly when it involves a storyline and multiple objects, each of which can move in a different way. A basic approach is to design such animation sequences using the following steps or procedures, such as storyboard layout, object definitions, keyframe specifications, and generation of in-between frames. The storyboard is an outline of the action which defines the motion sequence as a set of basic events which are to be taken place. The storyboard could consist of a set of rough sketches along with the action, so the name storyboard. An object definition is given for each participant in an action, where objects can be defined in terms of basic shapes such as polygons or splines, surfaces, etc. A keyframe is detailed drawing of a scene at a certain time in the animation sequence. Within each keyframe, each object is positioned according to the time for that real frame. Some keyframes are chosen to extreme positions in the action, others are spaced so that the time interval between keyframes is not too great or larger. And in between, that is generalized in between, are the intermediate frames between the keyframes. The total number of frames and hence the total number of in between in-betweens needed for an animated is determined by the display media that is to be used. Traditional animation technique includes object deformations, spacing between animation frames, motion anticipation, and follow through and action focusing. One of the most important techniques for simulating acceleration effects is squash and stretch, where as the ball accelerates, it begins to stretch when the ball hits the floor and stops. It is first compressed and then stretched again as it accelerates and bounces upwards. Another example or technique we have is used by film animators, which is called timing, which refers to the spacing between motion frames. A slower moving object is represented with more closely spaced frames, and a faster moving object is displayed within fewer frames over the path of the motion. The next topic to be discussed is some general computer animation functions, where some animation packages such as Wavefront, for example, which provide special functions for both the overall animation design and the processing of individual objects in it. A set of routines is often provided in general animation package for storing and managing the object database. So which mainly depends on some of the standard camera functions or motions such as zooming, panning, tilting, etc. Moving on to some of the OpenGL animation procedures, we have glut init display mode, where we are initializing the glut double buffer, which provides the two buffers called the front buffer and the back buffer, which we can use alternatively to refresh the screen displays. We can specify when the roles of the two buffers are to be interchanged using glut swap buffers. And to determine whether double buffer operations are available on a system, we can issue the following queries such as gl get boolean function, where we are considering double buffer with the status. And for continuous animation, we can also use glut idle function, where we are providing the animation function of the program, where the parameter animation function can be assigned the name of a procedure which is to be performed the operations for incrementing the animation parameters. Raster operations and color index assignment functions are available in the core library, and the routines for changing color table values are provided in glut. Other raster animation functions or operations are available only as glut routines because they are dependent on the Windows system in use. In addition, computer animation features such as double buffering may be included in some of the hardware systems also. That completes your chapter of computer animation regarding OpenGL prescribed for the syllabus. If you like the video, share it, like it, subscribe it. Thank you.